Now we're going to look at zeros of a polynomial function. We're going to start by looking at the rational zeros theorem. And the rational zeros theorem says, okay, so if you have a polynomial, then all the possible rational zeros for that polynomial are the factors of a sub 0 divided by the factors of a sub n. And really the factors of a sub 0 is going to be the factors of your constant term over the factors of the leading coefficient. Because a sub n, again, is your leading coefficient, and a sub 0 is going to be your constant term. What the rational zeros theorem tells us is if you're going to have a rational zero, and a rational zero means that it's either an integer or a fraction, if you're going to have a rational zero, it's going to come from these possibilities. It doesn't mean that these numbers have to be a zero of your polynomial or a solution of your polynomial. It's just the possibilities. If you had one that's an integer or a fraction, it's going to come from that set of numbers. So when we're solving for a polynomial, when we're finding all the solutions, all the zeros for a polynomial, we're going to be using the rational zeros theorem to determine what the possibilities what we could possibly have as an answer. So now let's just practice using the rational zeros theorem, and we're going to use it to just list for the moment, all the possible rational zeros of the polynomial. Well, how do we do that? Again, possible rational zeros, and I'm going to abbreviate it as PRZ for possible rational zeros, is equal to the factors of the constant term. Well, if I look at my function here, my constant term is 15. So factors of 15 over the factors of the leading coefficient. Leading coefficient is going to be the number in front of x cubed. There's no number there, but I know that there's always an implied 1. So let's start with the factors of 15. Well, let's see. What multiplies to 15? We have 1 and positive 15, but we also have negative 1 and negative 15. We have 3 and positive 5, and we also have negative 3 and negative 5. So those are all the possibilities for multiplying to 15. Well, how about 1? Well, the only options there is 1 times 1 or negative 1 times negative 1. So that's the only options there. Well, if you notice here, I have a positive 1 and a negative 1, a positive 15 and a negative 15, a positive 3 and a negative 3, a positive 5 and a negative 5. In the denominator, I have a positive 1 and a negative 1. When you're doing this, you don't really write or list out all your factors this way. Since you know that 1 is a factor and that it could both be positive and negative, we write plus or minus 1. Since we know 15 is a factor and that it can be positive and negative, we write plus or minus 15. Same thing for 3, plus or minus 3, and plus or minus 5. And this is all divided by plus or minus 1. Well, now all we have to do is clean up. So again, we're just listing the possibilities, what we could possibly have as a zero. Not our real zeros, but the possibilities for zeros. So when you look at this, I just want you to ignore the plus or minus. You're always going to be writing a plus or minus. When you're cleaning this up, what you need to do is think, okay, if I take 1 and I divide it by 1, I'm just going to be left with 1. 15 over 1, 15. 3 over 1, 3. 5 over 1, 5. So the possible rational zeros, if this function has a rational zero, these are the possibilities for the zeros of that function. All right, let's look at the second example. Same thing, list the possible rational zeros for the function. The possible rational zeros are equal to the factors of the constant term. Let's see, what multiplies to 6? Plus or minus 1 and plus or minus 6. Because it's positive 1 and negative 6, or negative 1 and positive 6, and then plus or minus 2 and plus or minus 3. Then they divide by the leading coefficient. What multiplies to 10? Plus or minus 1 times plus or minus 10, and plus or minus 2, and plus or minus 5. So those are all my possibilities. Well, I need to clean this up just like I did last time. Last time it was actually easy because the only thing in my denominator is 1. This time I have a lot of stuff in my denominator. So let's look through how we would clean this up. So I'm going to start with just looking at that as my denominator. So if I have 1 over 1, I'm left with plus or minus 1. 6 over 1, plus or minus 6. 2 over 1, plus or minus 2. 3 over 1, plus or minus 3. Okay, well, what if I'm looking at the denominator of 10? 1 over 10 is plus or minus 1/10. 6 over 10, well, that reduces to plus or minus 3/5. Because again, if you think about it, 6 over 10 is equal to 3/5. 2 over 10, that reduces to 2 over 5, and then 3 over 10, plus or minus 3/10. Next denominator of 2, plus or minus 1 over 2, or a half. 6 over 2, well, 6 over 2 is 3. Do I already have a possible rational zero of 3? I do, so I don't need to write it twice. 2 over 2. Well, 2 over 2 is 1. Do I already have a possible rational zero that's 1? I do. Again, I don't write it twice. Finally, 3 over 2 plus or minus 3 over 2. One more denominator, the denominator of 5. 1 over 5. So plus or minus 1/5, 6 over 5, plus or minus 6/5, 2 over 5. Well, don't I already have a denominator of 2/5? I do, so I don't need to write it again. And finally, plus or minus 3 over 5, which I already have. This example, example 2 of f of x equals 10x cubed plus 7x squared minus 2x minus 3 has 12 and actually 2 of each one of those, so 24 different possibilities for zeros that are rational for that function. We talked about how to find the possible rational zeros, but actually, how do we solve polynomials? How do we actually find those zeros? To find the zeros of a polynomial, the first thing we want to do is we want to list out those possible rational zeros. So we want to list out the possibilities. Then we're going to use synthetic division to figure out, right, which one of those possibilities is an actual zero, is a real zero of the polynomial. But we're going to have a graph, just like you see in this example down here, to help us do that. Once we've found a zero and done synthetic division, we end up with a new polynomial. So if that new polynomial is factorable or a quadratic, we finish solving it by what we already know how to do, because we know how to solve all quadratics and we know how to factor. If that new polynomial isn't factorable and isn't quadratic, then we have to go back up, perform synthetic division again with another zero, and keep going until we get to something that we can solve. So now let's look at a couple examples of finding all the real zeros of the polynomial. So example 3, we have f of x is equal to 3x cubed minus x squared minus 15x plus 5. Step 1, list all my possible rational zeros. So possible rational zeros. So we're looking at factors of 5. So plus or minus 1 plus or minus 5 divided by factors of 3 plus or minus 1 plus or minus 3. Clean this up. So that's going to equal 1 over 1, we have plus or minus 1. 5 over 1 plus or minus 5. 1 over 3 plus or minus 1/3. 5 over 3 plus or minus 5/3. So if I have a rational zero for this function, it's going to be one of these choices. Step 2, we use synthetic division to figure out, well, are any of these zeros a real zero? Well, let's take a look at this graph. That's why this graph is there. Here are all my possibilities, positive or negative 1. Well, in order to be a zero of the polynomial, remember I also said that that's an x-intercept as well. So what we want to look at is we want to look at the x-intercepts. So do we have any x-intercepts at 1 or negative 1? Well, let's look. 1, negative 1. No. Well, that means that that's not a possibility. That's not going to be a real zero of my polynomial. What about 5 and negative 5? Nope. Right? What about a positive 1/3? Ooh, maybe. It looks like maybe this point right here is positive 1/3. So I'm going to go ahead and try synthetic division with positive 1/3. So 1/3 goes on the outside, cubed, squared, linear, and constant. So let's write those coefficients down. Right? Bring down your first term. 1/3 times 3 is 1. Add down, negative 1 plus 1 is 0. 1/3 times 0 is 0. Add down, negative 15. 1/3 times negative 15 is a negative 5. Add down, and I get 0. So is 1/3 a zero of the polynomial? Yes. How do I know that? Again, according to the remainder theorem, I'm a zero if my remainder is 0. So great. Well, what polynomial is this? Well, this is, remember, if this is an x cubed, this is an x squared plus 0x minus 15. So now we're at step 3. It says once you find a zero, we found a zero, a third is a zero. If the new polynomial is factorable or quadratic, well, is this a quadratic? It is. So what do I need to do? I finish solving using methods I previously learned. So I need to solve what's left. So what's left? Well, 3x squared. I don't write 0x minus 15 equals 0. So this is the polynomial that's left. Can I solve that? Yes. How can I solve that? Well, I could do this by extraction of roots. Move 15 to the other side, divide both sides by 3, and I get that x squared is equal to 5. Take the square root of both sides to solve, and I get x is equal to plus or minus the square root of 5. So I have 3 answers for this polynomial. One of them is that 1/3, that 0 that we found earlier. The other 2 are right here, positive and negative root 5. This is my answer. These are the real zeros of the polynomial. Let's look at one more example of this. So I have x cubed minus 2x squared minus 11x plus 12. Step 1, list your possible rational zeros. So my possible rational zeros are equal to plus or minus, let's see, 1, and 12, 2 and 6, 3 and 4. Right? All of these divide over plus or minus 1. So that actually equals plus or minus 1 over plus or, oops, forgot my plus or minus with my 12 there. Plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. Take a look at your graph. Which one of them are actual zeros? Well, let's look. Do I have a plus or minus 1? Looks like I have a positive 1 as a 0 here. So let's try synthetically dividing by 1. So 1 on the outside, and then we have cubed, squared, linear, and constant. So 1, negative 2, negative 11, and 12. Bring down your 1, multiply, add down, multiply, add down, multiply, add down. Great. So 1 is a 0 of my polynomial. Well, what type of polynomial do I have left? Again, if this is x cubed, this is x squared, x and 12. Is this quadratic? Yes. Do I know how to solve quadratics? Yes. So let's go ahead and solve my quadratic. I have x squared minus x minus 12 equals 0. Does this factor? This actually does factor as x minus 4 times x plus 3. So when I solve it, I get x is equal to 4 and x is equal to negative 3. So I have 3 answers for this. One of them is the 1, the 0 that I found earlier, and then I found 4 and negative 3. In the next couple of videos, we're going to start talking about the fundamental theorem and complex roots as well.